Chapter 21: Adversarial Machine Learning and AI Attacks. In the ever-expanding digital universe, artificial intelligence is not only a guardian of cybersecurity but also a battleground for emerging threats. As machines grow smarter, adversaries evolve alongside them, exploiting their vulnerabilities with precision and cunning. One such sophisticated challenge is adversarial machine learning, a method that manipulates AI systems by subtly altering inputs to deceive their decision-making processes. Imagine a world where an AI system, trusted to differentiate between safe and harmful, is tricked into letting the wolf into the fold. Let's delve into the mechanics of these threats and the strategies that can turn the tide in this high-stakes game. What are adversarial attacks? Adversarial attacks operate in the shadows of AI's decision-making process, exploiting minute changes that evade human detection but drastically skew machine interpretations. It's like changing a single note in a symphony, undetectable to most ears but enough to throw the orchestra into disarray. These attacks manifest in different forms, each uniquely crafted to undermine AI systems in critical ways. Evasion attacks, slipping through the cracks. Picture an AI system trained to identify malicious network activity, a digital gatekeeper standing between safety and chaos. In an evasion attack, a clever adversary subtly alters the malicious data to slip through undetected, like a master of disguise fooling even the most vigilant guard. For instance, in image recognition, an attacker might slightly tweak the pixels of an image, creating an illusion that the AI misclassifies. A stop sign might suddenly register as a harmless billboard. In cybersecurity, such attacks might involve modifying malicious payloads just enough to avoid detection by intrusion systems, opening doors to larger breaches. Countermeasures for evasion attacks. Adversarial training. Teach the model to recognize and resist such manipulations by introducing adversarial examples during training. Defensive distillation. Employ soft labels from another model to create a system less sensitive to subtle changes. Feature squeezing. Simplify data inputs, such as reducing color depth in images, to leave less room for adversarial manipulation. Poisoning attacks, corrupting the source. Now imagine an AI chef crafting recipes based on a corrupted cookbook. This is the essence of a poisoning attack, where the attacker contaminates the training data itself. The corrupted foundation compromises the AI's decisions, often in ways that serve the attacker's objectives. For example, an attacker targeting a spam detection system might introduce emails that mimic legitimate communication but embed malicious intent. When the AI learns from this tainted data, its ability to distinguish spam from genuine emails deteriorates, leaving the system vulnerable to exploitation. Defensive strategies. Robust optimization. Fortify the model against poisoned data by reducing its sensitivity to training anomalies. Outlier detection. Actively hunt for and remove anomalous or suspicious data points before training begins. Fortifying defenses, building resilient AI systems. The adversary's tools are ever evolving, but so are the defenses. Let's explore the mechanisms designed to make AI systems not just smarter, but stronger. 1. Robustness techniques. Armoring the AI. Building resilience against adversarial attacks often begins during the training phase. Here's how robustness techniques fortify AI systems. Adversarial training. A hands-on approach where the AI confronts manipulated data during training, learning to outsmart adversaries before deployment. Defensive distillation. A two-tiered approach that uses the insights of one model to fine-tune another, creating systems that are less reactive to small, malicious tweaks. Feature squeezing. By compressing data inputs into simplified formats, this technique limits the adversary's ability to exploit subtle variances. These methods are not without their challenges. They often require balancing robustness with accuracy, ensuring the AI remains both secure and effective. 2. Detection methods, spotting the intruders. Sometimes the best defense is a sharp eye for deception. Detection methods aim to identify manipulated inputs before they can wreak havoc. Statistical anomaly detection. Establish a baseline of normal behavior and flag deviations. For example, in network traffic, An unusual surge in requests from a single IP address could signal an attack. Ensemble-based detection. Cross-check predictions across multiple models. If one model's output differs significantly from the others, the input might be compromised. Feature squeezing. Doubling as a robustness measure, this technique can also reveal discrepancies in manipulated data. These detection strategies act as the AI's early warning system, empowering organizations to act before an adversarial attack causes significant damage. The stakes. Why defenses matter. Adversarial AI attacks are not confined to laboratories or theoretical scenarios. They are real, evolving, and targeting systems that underpin modern life. From autonomous vehicles and facial recognition systems to financial fraud detection and critical infrastructure, the potential impact of adversarial attacks is vast. Imagine an attacker manipulating an AI that monitors power grid stability, causing cascading failures across cities. Or consider a poisoned AI in healthcare, misclassifying medical scans, leading to incorrect diagnoses. These are not mere hypotheticals, but cautionary tales highlighting the urgent need for robust defenses. Looking forward, a continuous battle. The fight against adversarial attacks is a chess match in the digital arena, an unending cycle of innovation and counter-innovation. As attackers devise more sophisticated strategies, defenders must anticipate, adapt, and outsmart their moves. It's not just about building smarter systems, it's about building systems that can withstand the inevitable challenges of an adversarial world. In this landscape, where AI is both the shield and the battleground, resilience is key. And as we push the boundaries of what machines can achieve, we must remain steadfast in ensuring they are secure, trustworthy, and capable of standing tall against the rising tide of adversarial threats.